Automation is changing the world. We all know that. And a lot of times on the MTD channel, we talk about automation, cobots and robots inside of turning centers and milling centers. But look at this big mamma jamma. I mean, this is a beast right here. And the amount of technology, expertise, and excellence that goes into a project like this, one that's unique and never been done before, takes a team of experts to do so. I got Ethan with me today, and he was in charge of the robotics side and the CAD side, which, yeah, kind of important when it comes to a setup this large. So Ethan, let's just quickly go over what this project is, what makes it unique, and then let's get into the robotics and CAD side of things.
Certainly. So we have a series of telephone poles that our customer wants to add printing to and machining to. And we also want to be able to handle those poles with the robot so we can do a kind of a continuous operation. So the operator will load it in on the in feed behind me. Robot will process it through, drop it on the out feed, and while all that's happening, we can still bring another pole in. We're never actually stopping the process.
Telephone poles, we don't hear that every day, you know?
No, but apparently a big issue out in California with the wildfires is the telephone poles falling down. These actually have a little bit better lifetime under those conditions. So
that's such a curious thing. I'm happy you brought that up as well.
Yeah.
To my understanding, when we're talking about these telephone poles, there's different lengths and different diameters and all sorts of speed bumps into making sure that this thing works.
Certainly.
And you had to do that. What were some of the obstacles and how did you overcome them?
Certainly. So, I mean, the largest pole that we've designed the cell to handle is 50 foot long, about 15 meters. So we have to have a big enough space, a big enough rail, a big enough everything that we need to handle that system. We also go up to about 700 kilograms with one of the parts, or it's about 1,500 pounds. So. Whew. Yeah, it's a pretty heavy payload. That's why we chose the M1000 1,000 kilogram payload from FANUC. You know, it does a good job of handling these parts, and we can actually lift these up and go about 600 millimeters a second on some of the smaller parts, full speed swings, getting there. So it's a pretty big beast.
Why not? And I know you know this answer, and I'm sure there's some audience members out there watching and going, Tony, why did you ask that dumb little question? But why not grippers? Is it because of all the different sizes and changes? Grippers are so popular.
Certainly.
And to my knowledge as well, this is one of the less utilized or newer options.
Sure.
And you guys have decided to go with it. Why not grippers? Why not something like that?
Certainly. So grippers, you'd have to have either a really large, really expensive gripper to handle the entire size range, or you'd have to have lots of grippers, which with the tool changer this large for this size payload of a robot, you're going to add up costs pretty quickly. The hook also does another thing for us. It allows us to keep maintenance down. So grippers are also a failure point, right? So if we have a hook, there's not a lot of failure points other than mechanical failure of the hook. So it'll actually do that job without the additional costs of maintenance.
Well, I know we all like the answers to that because I kind of felt like there was some safety involved in that as well. Some expenses certainly involved in that. So tell me the benefits. You kind of did already, but this specific one from FANUC, there's the way that it turns. It obviously can pick up a whole bunch of different sizes. It has a payload to handle it. You're moving it from one side to the other side. You actually have a chuck on this side. You have a piece. Oh my gosh, there's so much to this, Ethan. I'm going to let you talk about it. But this setup, why this robotic setup?
Certainly. So we had to go with a big enough robot to handle that payload. As we said, we went all the way up to M1000 because it's way more flexible than some of the M2000s start having some joint limitation issues. We went with the 7th and 8th axes here. We've got the rail and the rotational positioner, and we call it the lathe, that allows us to access all sides of the part when we're doing some of the machining and the printing that we do on the part. But as far as just the general setup, we needed something large enough while also being flexible enough, and this is kind of where the FANUC line just kind of crossed for us. So,
Ethan, I've walked into a lot of shops and seen some really expensive boat anchors out there from some machines that aren't being used the correct way, and CAD plays a big part of that. Can we talk about the CAD side of things? Make sure it's communicating correctly with both aspects, front and back end.
Certainly. So CAD is the engineering layer for how we lay out this system, right? If it doesn't fit together, even if it looks like it's good on paper, it doesn't work in reality, you have to make that step as an engineer. As far as the part CAD, which I think is kind of what you're going to allude into next, we actually have a CAM software that can communicate in TP code for the robot that will take the existing holes in the 3D CAD of the model and provided by the customer of the part itself, and it will interpolate those holes right for us. So we're using a 1/2 inch end mill to do 7/8 inch or approximately 7/8 inch size features on the pole. And programming on that is minimal because we have this CAM package that goes along with it. The CAM package is called Robot Master. And I'm sure we'll get into that a little bit later. So
yeah, well, let's talk about Robot Master right now. Let's go ahead and dive, since you brought it up, let's dive into it. Because I do want to learn about how this was maybe previously being done, or some of the complications before IC automation came in and saved the day for these guys. But let's talk about Robot Master first.
Sure. So let me hint at your question about how it was done before. Before they didn't have a robot on it, they were kind of stuck with a single end mill that would only hit exactly where it hit. It was a really hard time to add slots in their system. They didn't have the functionality and the flexibility that we get with the robot. As far as the CAM software, that just adds to the flexibility. We could program all these holes in the robot, but it would take us much more time than and our customer has to do custom holes after the fact. It would take them a lot of time to sit there and add a hole and do all of the moves that a robot requires. I think it's 60 moves just to interpolate a 7/8 inch diameter circle with linear moves, right? So we want to keep everything quick and moving and flowing and allow them to do new products. So that's what the CAM software allows us to do. So.
And this is a fairly flexible system in the realm of something that's going to run 24/7 because there are so many unique pieces. Sure. And some of these poles are being kind of put together like Legos, right?
Getting there, yeah.
I know Legos is how my basic brain works because I love to play with Legos, and you stand on a much higher precipice of how it actually works, right?
Yeah.
But there was some flexibility in the old way of doing things, the new way of doing things, but also how can we make it truly practical to bring everything that these clients want to a reality? And you were able to do that through the robotics and CAD system.
Yeah, as I said, it adds a lot of flexibility. Right now, we can go over to the screen and I can just say we now have a part that's 3 inches bigger, and it should run it as long as it falls within the range that we designed for. Again, we can go up to 700 kilograms. We can go as long as 50 feet, 15 meters. So as long as we fall in that range, this robot should be able to handle it. And really, because it's designed the way it's designed, both on the CAD and the software side, we don't have to do much other than say do it.
Ethan, I'm actually glad I'm going to give you a high five for that, because you made me think of something else that I think the audience probably wants to know about that we haven't discussed today, and that's ease of use.
Yeah.
We're talking about big poles. We're talking about a big robot. I'm willing to bet the investment wasn't small.
No.
And you just described that fairly simply, the customer can just push a few buttons in the system and they have everything they need. Can we talk about the ease of use, simplicity, how you've set it up for them?
Certainly. So the flexibility we have allows us a lot of options. A couple of ease of use things that we would have in this cell would be the recipe setup on our HMI. We can literally just tell it the diameter of the pole, the length of the pole, the center of mass, a couple other parameters. We got a whole screen of them. And it just adapts, right? I don't have a different program for each pole other than the CAM software, which they just run the new CAM and send it to the robot, and it calls that one automatically. As far as other ease of use things, things like recovery, this has got recovery built into it. So say you hit an e-stop or you have a power outage, in the middle of any part of the process, the robot should be able to recover and just keep moving forward. So
I think you've nailed everything, Ethan. I want to leave it open for you because it's very obvious to me that you have a level of wisdom that the audience out there is going to admire and want to learn as much from you as they can. So I'm going to leave it open. Specific question. And just say, is there any messages you'd like to give? Because I know IC Automation is really that unique company that takes on those difficult jobs. You make all of your own parts in-house. You make sure it can all be put together. You test it. Obviously, the robot's not from IC, it's from FANUC, but we know the general rule of what I'm saying here. Is there any messages you'd like to say to the people out there looking for that difficult project, looking for a partner company with great service and support that will take care of them? Because that's really the difference between someone who's just come in and says, I can do that too, and someone that's been doing it successfully proven is IC Automation. Is there any messages you could give to them?
I mean, we as a company take a lot of pride in making things work. We don't send anything out the door until it works. Like this is going to Utah. It's not going to go to Utah until it's ready. Luckily, it's ready already, and we don't have to fight that battle anymore. But no, as a company, we really pride ourselves in making it work. We want it to be easy. We want it to recover. We don't want anybody to have to get on the teach bendit for any reason. It should all be accessible from the HMI. It should be flexible programming, recipe-based systems that allow us to make small changes or add new parts without a lot of complexity, a lot of overhead, a lot of even calling us, right? Like you want a service call, we'll help you with whatever you need, but you guys should be able to add a part with minimal complexity and not need to call us, which we have enabled with this kind of system. So.
And you, my friend, have been doing this pretty much since day one of IC Automation. So
pretty close.
Its birth, its growth, its current success and expansion, going into 80,000 square foot building coming up. everything you just said, it means everything to you. What you're growing is so very important. So that message, for everyone who's receiving that message, it is absolutely just not a sales pitch of a guy who showed up today to be on camera and say, I'm here, I'm an actor, and I'm going to say what you told me. No, this is real. This is where your heart sits, isn't it?
Yeah, I mean, absolutely. I love my job. I love doing what we want to do, and I love making it work right. Like, I don't like to send anything out or do anything that doesn't make it easy for our customers. It doesn't, it's my own headache, right? I feel bad if something's not perfect. So we're going to make it right. We're going to get it there, and we're going to make it easy to use. So.
Ethan, you said it better in closing than I ever could have. I love to make it work right. That's Ethan's words. This is IC Automation, and this is one heck of an awesome sell. If you guys have a project out there, look up IC Automation. They're ready to take care of your needs as well, Ethan. Well done, my friend.
Thank you.